In this video, what I would be looking at, we would be looking at what exactly do we mean by sets. Sets essentially, it's just a well-defined collection of objects. So your objects can be anything, numbers, alphabets, anything for that matter. Okay, what do we mean by well-defined? We mean by well-defined that it might have certain properties. So each member of the set would, satisfy that properties. For example, if we look at a set of all vowels, okay, so that would mean that it is a set of which contains A, E, I, O, U. So all the elements here are essentially vowels and nothing else. Okay, so that is a property that the elements of this set are satisfying. Now you denote set generally as, within a curly bracket. Okay, this is the most general representation of a set. Okay, now sets are always denoted, mind you, sets are always denoted by uppercase letters. So by your alphabets, which would denote by alphabets which are in capital. So by alphabets in capital or uppercase. Okay, so say A, so capital A, capital B. Okay, and what about this is for set. What about member of sets? The elements, member of sets are known as elements. Okay, elements of sets, they are denoted by lowercase letters like A, B. So lowercase letters. Okay, and there's a very important set actually in mathematical analysis, which is the null set. This is the null set. A set that contains no element. Okay, a set that contains no element is denoted as phi. This is the symbol for phi. Okay, now what happens, why do we require this symbol, is essentially, probably there is a certain property which a set has to follow. Like for example, let me just give you an example of it. Say you're looking at a set of all x's such that x belongs to the set of all natural numbers, and the property that it has to satisfy is that it lies between 1 and 2. Now no natural number lies between 1 and 2, right? So this actually equals to phi. This such kind of a set equals to phi. So similarly, for example, you can have a set of of all x's such that x is a real number, such that x square equals to minus 1. This set will also be equal to phi. Why? Because there is no such real number. Okay, so that's why you require to denote such kind of a void or null set. Okay, now again another thing, that I would like to ponder upon, I would like you to ponder upon, is what are equal sets? What are equal sets? You know, sets are called equal, okay? A equals B if every element of A, okay, if every element of A is in B and vice versa. So every element of A is in B and every element of B is in A, then you call the both sets to be equal. Okay, this box tells us what two equal sets mean. Okay, so that's what I would like to talk about in this video. And next, let's see, in the next video we will talk about what are the properties of sets, what are the operations we can have on sets.